generative and interesting culture, yeah, that allows the experimentation and the risk taken by the software development. This is how many very cool products are also created. Uh, if we fail, we can learn, and if we learn, we can do better our work. That is how we can apply this principle. And let's take a look now to the basic practices of DevOps. Continuous testing. Yeah, testing means that we test the software in a very automatically way, almost with no human intervention. We create different kind of testing. For example, unit tests, integration tests, acceptance tests, performance tests. We test also in different environments, local development, quality assurance, UAT, staging, production. We create different environments where we can also continuously test. And of course, when we test, for example, on development, we can find problems before the system goes to production. And we can use tools to automate and verify the code quality. Shift left testing means that we don't test only the deliveries or the artifacts that we build. We move also the testing to the parts or to the steps on the left side. For example, we verify new requirements, we verify also new code, we verify each build. That is what shift left testing means. Not only test the artifacts that are built, that are delivered, but also to test previous steps. Okay, these are of course the advantages of shift left testing. And also another very important practice of DevOps is the continuous integration. That is one of the important DevOps practices, continuous integration. What does it mean? It means that we automate the integration of the code that was produced by different developers into a single project. We use the idea is to use a central repository where all the changes are integrated, and we, for example, here we can see it graphically. We have different developers. Each developer, we have also one central repository. When one developer do some changes on the code, they push the changes on the repository. Automatically, the continuous integration tooling realize a quality check, and if the quality check is correct, we build the software. We build the software with the change that was made. The second developer does exactly the same. When he is finished or she is finished, he push or she push the changes on the repository. Automatically, a quality check will be done, and we have a second build. And the history will be repeated with the next developer, and so on. That is the continuous integration is assured within these different steps. And another important part, the continuous delivery, is an extension of the continuous integration. It means that we don't not only create or verify the new code that the developers push into the repository and build it. Yeah, we do also some automating tests, and also each change is automatically deployed into a development or test or production environment. And this the continuous delivery is also means that a team is really ready to deploy software at any time. It does not mean that the software shall be deployed continuously or all the time. Yeah, but the idea is that the deployment is ready at any time. Because here we have another concept, the continuous deployment. Continuous deployment is it goes one step beyond the continuous delivery. It means that all changes goes directly to our customers. There is no human intervention, and this is really a very important way, to or we need to assure that all these changes that automatically goes into production shall be really tested completely. And of course, the continuous deployment has the difference that with continuous delivery is that on continuous deployment everything is into deployed into production. Imagine that you do, I don't know, 30 changes daily on the code. Then you will have 30 deployments on production. I don't know what can we deploy 30 times at a day. If there are 30 new features, maybe not. Therefore, continuous delivery is maybe more significant because you are able to deploy at every time, but you not deploy all the time. You deploy only when you need to do that. For example, there are different changes that are done by the developers, and some or a group of these changes made a specific features. Then I can collect all these changes, and then only then, when everything is finished, then I can deliver the software with this only new feature. Okay, and if we see here the continuous integration, we have here a similar way. What the intention of this diagram is that you can see the difference between what is automatically done, what is a manual processes. For example, if you see all the developers push some code onto the repository, and automatically the new code will check, for example, using unit test, integration test. Also, it is important to see how many we test on the code. And when everything is okay, we build and we deploy into a specific environment. And maybe we can also deploy automatically to an acceptance environment that can be test automatically or manually. And in the end, also we can say if we use continuous delivery, we can say, okay, now deploy. Then we deploy to UAT, and we can also deploy to production. But of course, only when it is needed. There is no automation, and this is the idea of the continuous delivery, continuous integration, and so on. Okay, this is also a very important practice of DevOps, the feature toggles, because if you have, let's see, you have, for example, a system. The system is made about 4 functions, and you say, okay, I want that the function C is visible or is usable on a specific environment, for example, on development or on UAT and so on. Also, what we can say is the same system, exactly the same system, we can say in a configurable way that the function C is not visible. And then means that in the end, we have the same system in different stages, but in one stage, we have a function that can be used, for example, the function C, and in another stage, we can hide this function. This is really very, very important, because you can, without problems, do some kind of continuous deployment. Every time you can, for example, implement the function C. The function C is maybe not yet ready. Can be this part that is ready can be tested on UAT. But if you don't want to activate this functionality on production, you can say, okay, this functionality shall not be usable, and then you can hide, or you can you can hide this functionality on some specific. This is really very important when you have a kind of continuous delivery or continuous deployment strategy, and you want to disable some feature that is not yet ready for production. Okay, let's speak about another important part: continuous software architecture. What are here the important message? We need to go from the development of projects to development of products, because a project has normally a deadline. A product is something that we will evolve in many years. That possible does not have an end. And what if for DevOps practices, it is better to implement or to develop not projects, but better to develop products. Also very important for DevOps, in the software architecture part, we need to take more care about quality attributes. And we need to delay design decisions till are absolutely necessary. Because if we take some decision previously or on very earlier or earlier, then can be that later this decision is really very hard to roll back. And also we need to try to create software that are not really small, or are made by modules, or because if you see the principles of DevOps, what through this flow, what goes to this flow is the artifacts that we create. And if we create, imagine that we create a software, a very monolithic software that is really big. Then to transfer, to try to bring all this big ball into this stream is really very complicated. It's easier to move something small on our value stream. And also it is important, our software needs to be buildable, testable, deployable, and needs to be operate. And in the one of also very important part, this has the name reverse Conway's maneuver, is to try to design our IT teams according the design of our system. And what is important, which topics are important, or which topics with which technologies, methodologies are important, or support DevOps. For example, domain-driven design. Using domain-driven design, you can split a problem in a business way, in different subparts. And what you get is these different small subparts. Each of these small subparts can be put into a value stream, into a CI/CD pipeline, and it can be deployed, or it can be developed in a really a very easier way. Also, very related with domain-driven design and also with DevOps is the kind of architecture that you choose. One of the best fit architectures that we can use to allow or to implement DevOps is, for example, microservices, self-contained systems architecture, micro frontends, event-driven systems. And also all these kind of modern architectures are also very related with domain-driven design. Also a very important technology that allows or do easier the implementation of DevOps is the containerization technology. For example, things like Docker or things like Kubernetes are really technologies that allow us to implement DevOps easier. Of course, we can also implement DevOps with other kind of technologies, but these new technologies are really has very many advantages to be used on DevOps. And also another important part regarding software architecture for DevOps is the use of the cloud and everything that in the cloud is offered. Okay, and also another important part of DevOps is the continuous monitoring. As we saw on the three ways of DevOps, we spoke about the feedbacks, and one of the ways to give feedbacks is to measure something, and the continuous monitoring is very important because we can take in consideration using also different KPIs, key performance indexes. We can measure all different activities that we do. And using this information, we can learn and we can do the stuff better. And we can, for example, monitor how is the performance of the application, how the system performs, how is the behavior of the users, and the sentiment of the user. Okay, DevOps is based on different business and technological frameworks. Let's take a look inside that. The DevOps is there are on this point one. This is something that appears on the book of the DevOps playbook. They say that the basics or the foundation, the pillars of DevOps are in Lean, in the theory of constraints, and in the Toyota Kata movement, and also very important, DevOps is a continuation of the Agile software movement. What is Lean? Lean is a management framework that help us to create something, to produce something with fewer resources and less waste. And normally, and also the Lean has as main idea the continuous experimentation to exactly to achieve perfect value. This is something that we saw already also for the DevOps culture. Is something similar. Therefore, the author says that DevOps is based on Lean. Okay, Lean origins. Lean is really some old management way to do the stuff. It begins in the early century, in the early last century, and continues with the production system of Toyota, and then after that was enhanced by other authors. Another pillar of DevOps is also the Agile movement. The Agile movement is an iterative approach to manage the development of software. And if you see DevOps contains or this idea can be also so on DevOps. We have an iterative approach. We produce software, and after this cycle is finished, we get some feedback. Then comes a next iteration, and exactly is what the Agile movement says. There is some comparison between waterfall, Agile, and DevOps, and the difference is only the frequency of the deployment of the software. On the waterfall methodology, normally the deployment of the software takes or is made after 3-6 months, maybe 1 year. On the Agile movement or using Agile methodologies, the deployment of software is normally after one iteration that can take about, I don't know, maybe 3 or 2 weeks. And using DevOps, the deployment of the software can be really continuously. Yeah, and this is exactly what DevOps takes from the Agile movement. Okay, I think these are already also very well-known Agile frameworks. For example, Scrum. It is very known in the IT in the software development world. This is a framework, iterative approach where using iteration from about, I don't know, maybe 1, 2, or 3 weeks, you create some software and you produce some value to the customers, and you deliver this increment to our end customers. Then you get some feedback, and then come the next iteration, and so on. It is better or it matches better when we develop complex software. On the other hand, we have also a Kanban is also an agile framework, and this is only about how to organize the flow of different activities. An activity comes, then we'll queue, and then we'll begin work, and someone is done, then come the next activity, and so on. Yeah. ITSM is a very not light framework that was made to provide to allow the IT organizations to see the different to put or to convert what an IT organization does in form of services. For example, there is some group that is there to, I don't know, to deliver machines, to deliver computers, to deliver laptops, and then with using ITSM, the companies, big companies, normally it is made for big companies. Therefore, they at the beginning they say that ITSM or ITIL is not compatible with DevOps. Yeah, because this idea, but is really also many of the ideas of ITSM are also in the DevOps movement, with the definition of the different teams that do some operation, some functionality, and so on. And for example, that is one processes that is served as a service in the companies, and this is what the companies define using ITSM. And this is also, as we saw, this is also a pillar of DevOps. And ITIL is only a specific implementation of ITSM. Okay, here we have a similarity. ITSM is like Agile, and ITIL is like Scrum. One is the methodology, and the other is the framework that implement this methodology. Okay, there are also other important frameworks that are important part of DevOps, like safety culture, learning organizations, continuous founding. And let's take a look to the tool change that we use for DevOps. For example, for continuous integration and continuous deployment, there is a lot of tools that can be used to implement continuous integration and continuous deployment. For example, one of the most popular is Jenkins, is a free tool. There are also other commercial tools or maybe also other tools that are related with specific platforms, like, for example, GitLab, or for example, Travis CI, and so on. These are tools that can be used to define or to set a continuous integration and continuous deployment pipeline. To automate for infrastructure as code. Infrastructure as code means that every time or a system is normally made by different components. For example, a web application can contain a database, a web server where the backend runs, can be also be made by another server that serves a mobile application, and so on. We have their different infrastructure. And within infrastructure as code, we, instead of using a specific program to a clickable program to create infrastructure, we write code that creates the infrastructure in an automatically way. For example, there are different tools. For example, Terraform is a very good open source tool that can be used to create. Is very related with Kubernetes. And you can create different cloud services for different cloud providers to define infrastructure and so on. And you can see here we have different kind of tools. One also that is actually very used is Helm. Helm is something like a packet manager for Kubernetes. This is something where you define which components, which Kubernetes elements do you want to use in your application. And okay, of course, as we say, very important, in the tool chain for DevOps are the cloud services. Here I put only the main 3 cloud services. There are also others. And regarding the container technology and cluster management, we have one of the main container technology is Docker. I think it's not the only one, but it's the mostly used. And also for cluster management, we have also very used is Kubernetes. And you can find also these cluster management services in the different cloud providers like Google Kubernetes Engine, Amazon Elastic Kubernetes Service, and so on. Okay, let's take a look to an example of a CI/CD pipeline. This is a real life example. This is how we develop our software and how we deploy it on our infrastructure. Yeah, here we have also a team that writes software. Each developer commits the software into a tool with the name Git Bleed. This is a kind of a Git repository that we have on the cloud. And when the code is pushed, is commit here on Git Bleed, automatically we run or Jenkins, our CI/CD tool, is informed about the commits on Git Bleed. Jenkins starts a build using Java and Maven or Angular and NPM. Also starts, or when the build is done, start SonarQube to statically analyze the code that we produce, not only for Java, also for Angular code, TypeScript code, and then using Docker technologies, we create the images from the builds that we create, and we put these images on the Azure cloud in a container registry. And is now this image, this Docker image, ready to be used for the deployment. Then Jenkins also deployed using the already created image, Docker image used for the deployment. And using Helm, we create the infrastructure, or we deploy our containers, our images on Kubernetes in the Microsoft Azure cloud, and in that way we publish completely automatically the changes that a user, that a programmer does in a development environment. This is actually our automatic process. And for example, we have teams that are made by 6 persons, and maybe we have I don't know, maybe 20 or 30 commits daily, and we produce, we build, we create images, Docker images, we verify the code using SonarQube and so on, and we deployed all these 30, each of these 30 changes into a development environment in Kubernetes Azure. And using a deploy button or a job in Jenkins, we say, okay, we are now finished. We want, or we are finished with a chunk of functionality, or with a chunk of commits that we want to bring to UAT, and using this manual process and or the already created image from the container registry. Using Helm also, we deploy this information into UAT in Kubernetes, in the Azure cloud. And here also using a deploy, a manual deploy, we say, okay, our testers or our automatic tests are done, confirms that our UAT artifacts are correct. Then we deploy manually. It means the deployment is really automatic. We start the deployment manually only. That is the only manual process. But when we say deploy, then automatically the image, the last image, will be get from the container registry, and also using Helm, we produce the production environment, or we change the production environment, and we publish all the changes into our Kubernetes Azure production environment. This is how we create all this stuff. And if you see, we say that DevOps is also a change in the culture, a change in the organization. This is in our company. There is a team on the development part. There is also a team on the operation parts. For example, there are another team that are responsible for the Asia infrastructure, but using a kind of self-services for example, for us, for the development teams, we can really apply, or we can really deploy our changes very fast. But it means that the complete involved persons here needs to collaborate together. Okay, and to finalize my presentation, let's speak about the measurement, metrics, and reporting. There are, as we say, if we want to do something better, we need to measure it. And for example, there are different kind of metrics. One type is the flow metrics. It is possible to calculate the lead time. That is the time that takes when a customer has an idea and the time when this idea is completely implemented. The lead time can be normally is days. It is really not really, how can we say it, is not possible to have a lead time in seconds or hours. Normally to put some idea, some request made by a customer, it takes some times, but many of the work that we do here, or that we can do here, shall be automatically. Also, deployment frequency is how oft we deploy software in production or in app store. Mean time to restore means how many time takes to one team, to restore an interrupt service. Can happen, that some commitments are correct, or at least the quality gate is passed, and therefore the software is also deployed. But because other circumstances can be that the software does not work, and then it is necessary, and then the service is interrupted. Then the team needs to do something to put the service back to work. This is the mean time to restore. And change fail percentage is how many how oft we made fails when we develop or when we release software and so on. There is also some risk metrics. For example, how many dishonest commits do we have, or how many, say, complexity or backlog items do we have in our backlog? How complex are there? How fragile are there? And also, it is important also to have some cultural metrics. For example, the stress level, the collaboration level, the attracting and retaining talent. This is of course, and these are not the only KPIs that we can take. And I saw in different companies they have their own KPIs, but the relevance are possible these flow metrics that I show at the beginning. Okay, then thank you very much for your time. And if you have questions, you can do the questions, or if you want, you can send the questions to me using my email, or you can send the questions to our colleague here.
Hello,
Okay,
hello. Let me check, but I think we don't have questions. Of course, it was very well explained from your side. I don't know if you want to say anything else or if we should finish here. And one more time, thank you very much, Alfredo, for your time. It's always a pleasure to be here with you.
Okay. Thank you also.
Okay, then. So thank you so much. And that's it.
Okay.
Thank you. Bye-bye. Have a great night. Thank
Bye.
you.
Bye.
Thank you for being here with us. Thank you.
Okay, bye.